show you that how much time I filmed, how much filmed material I have. I actually made a picture. 14 hours and 20 minutes is what I'm having here, you see? Let me zoom out. Oh, wow. Oh, wow. A ton of editing. You understand why I'm making the movies a little bit fast-paced. Okay, hello everybody. For a new project, I have this little circuit. So this is a 555. This is a 4017 decade counter. And this is another 555. These are some diodes. Here are some LEDs. And pretty much what this is doing is saying here, plays the 5 notes from closing counters of the sad kind, the movie. And I believe it was dun, 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 something like that. I copied, I didn't make it, I copied from internet, I find it, and it's a pretty awesome circuit. I never built it in my life. I'm having some scrap 555 boards, 4 of them, this 4, and I'm looking for a fitting pretty much. I'm fitting what I'm having already made with the circuit. So this is the first time when I'm building it, so I prepared a little bit right now. I looked what I'm having and I decided to actually do it. And I'm using very scrapped. I really wanted to get rid of this very big potentiometers, scrapped also from miscellaneous boards. And this is adding a ton of space to this circuit, but I'll try to use what I have, and it's saying to use 500 kilo, but what I'm having here says 400 kilo. Probably is good enough. This was also a scrapped cardboard. I scrapped the pads from it. I'm repurposing it, not because I don't have cardboards, I have a ton of them, but it kind of fitted the size here, so I'm making use of it, even if it's a bit on the limit, but it's good enough. Probably here. You can see here I had some pads and they were glued. Okay. This size is like 4 or 5 millimeters wide. So I should probably put another one here for leverage, but I'm only using these 2 pads. If it will be a problem, I can glue another pad there and I will strengthen it. I have brand new 555s. Well, I didn't prepare the legs. This is my scrapped solder from miscellaneous boards. Let me prepare these pins. I should glue this board on top of that. Start low. This wire, I have no idea what it means. And it's going to clock enable. My 4017. No? Yep, here it is. So clock enable actually is to ground. I have no idea what this guy is doing here. I'm repurposing this already made boards with this project. And I also want to use these scrapped pads. So easy to put in and easy to take out, I hope. Yeah, I have very small potentiometers actually, but I want to get rid of these larger ones. Okay. Very nice. I'm not very sure what to do here. So I can put here and here probably a capacitor 10 micro. 10 micro here. Small enough. Holy fucking shit, look at the legs of this one. But it's small enough. 16 volts, 10 micro. The size is good. But the pins are fucking hell. Let me put some legs on it. Yeah, very, very shitty capacitor. On the legs side. My luck with it. And I also want to make visible the text, the marking on the capacitor. On the capacitor should be negative and here positive. I should take out this pad here. If I can, because it's glued right now. Fucking hell. Let me actually try. I did something. Yes. Okay. Looking a little bit ugly. Yeah, that's good. It's nice. And this will be the ground. So here like this. Yep. So that's one leg. It is like this. And I can actually see the writing, which is exactly what I want. So all I need right now is negative 1 to link it either there or there. Yeah, I really didn't plan for this capacitor. It just popped in the way. This is extra trouble. Usually normal people will throw away such small leg capacitors, but not me. There. This is what I wanted. This is what I want. Like that. Perfect. That's my negative rail. At least from the capacitor, and from there to there. Okay, it's perfect. So I believe this circuit here is practically a clock. It's clocking this chip. The only purpose of this is to oscillate. That's it. Or better said, how fast it's singing. Yeah, pin 1 here is to ground, and pin 8, which is this one, is to positive. Perfect. This is what I wanted all my life. 4 to 8. I need to link it. I believe this wire is already insulated, but to be absolutely sincere, I don't trust it very much, completely. And now pin 2 to 6. This is a rule to all 555 circuits. I'm always linking pin 4 to 8 and 2 to 6. Although this is not shown in the circuit diagram, but it is actually linked this 4 pin to pin 8 to positive rail. But it's doing it through this switch to probably to stop the oscillation. I will see later what is the real deal and how I can actually stop it. Probably I can put a jumper on the positive rail here and not power this entire circuit from somewhere else than how he is showing it. 100 nanofarads. Usually I'm using it very often in all my 555 circuits. This on pin 5 usually. So it's from this pin to negative rail somewhere there. This is very good for stability. It is recommended in 555 datasheet to add it, and I've always added for stability of the circuit. So I'm highly recommending adding 100 nanofarads to every 555 circuits that you are using. It is bridging because I have a ton of solder here. Yes, now it's good, it's not bridging anymore. Yeah, I'm having a ton of solder here, which is good, but it's not good for bridging. So let's see, I need a 10 kilo from pin 6 to pin 7 here. This one 10 kilo. 10 kilo. A very scrappy one. Too long. I always like 555 circuits because they work. I build quite a few in my life. I trust 555 circuits every time I'm building them. Like that. Pin 3, which is this one, will go here somewhere. Yeah, this capacitor, this 100 nanofarads here to the ground, which is on this other side. I can actually drag a wire underneath like that, maybe 100 nanofarads, but I really need a very small one. By the way, these are all scrapped, as you can clearly see, because I want more a bit more weirder capacitor. For the moment, I repurposed two very small capacitors, this one and this one. I should probably put now a longer wire. Better now than later, no? What do you think? Yeah, I like to have very visible components, the markings of them. Excellent. So this pin and this pin somewhere there. Usually it is not having that 10 kilo there. No, I don't think it's necessary, this 10 kilo here. So I will cut it out. So let's see, from here to positive here. Check this out, to positive there. And this one to pin 7. Good. And next, from here to here actually. So here. So this is crossing literally the negative path. Is a recipe for disaster, for a very nice short circuit, if I'm not careful about it. But I will build it in 3D, so I will add this height to it, and it will not be a problem. Very nice, very well. Here. Yeah, okay. I actually don't need this pad. Take it out, although it is already glued, but because it's here in the margin, maybe I am lucky. Come on. And voila, because it's in margin, I was a bit more lucky. Yeah, perfect. Actually, I promised myself I will add on all my 555 circuits a diode, a polarity protection diode, because I was stupid in the past. And if you are reversing the polarity, exactly the chip, it will blow up. So it's very good to add here a diode, 1N4148 polarity protection. So this should be like this. Let me actually check. Smaller leg diode, more shittier diode, pretty much. All of these are scrapped. I didn't buy one of them, and they are perfectly good. This is not absolutely necessary, but I burned one or two 555s because I inversed the polarity, and the chip will burn very quickly, not the other components. And the chip is a bit more nasty to replace it. So I'm speaking from absolute experience right now. Very bad experience actually. So let's see, it's 5 volts right now, and I should get a pulse. I should have a good response. Maybe my potentiometer is bad. I didn't check my potentiometer actually. So 2 mega. No, it's good, it's fine. Yeah, this is increasing because of that capacitor probably. I believe I have a bad component somewhere. I have no idea which is the bad one. I hope it's not that cheap. Let's test this capacitor on 10 micro here. Actually, I should discharge it first. Yeah, it's that capacitor. Motherfucker. And I build everything around it. very nicely. Shit, shit, shit. What a misfortune. No, it's good. It is good. It's 10 microfarads. Huh. This one maybe. I hope I didn't burn the chip. No, it's not the capacitor then. Maybe I burned the chip. Maybe I made a short. I overheat it, but I was careful. No, nothing. No life. Absolutely no life. Wow. Motherfucker. I should probably put a LED here. Yeah, it's working. It's working. And why the fuck my oscilloscope didn't show anything? So it's working fine. Very strange. My oscilloscope didn't show anything. Let me change this capacitor back as it was before. Yeah, it's always good to add an LED, a visual hint. And now I'm thinking to add an LED somewhere, somehow. I should choose a shitty LED. Let me actually test if this is working with this capacitor. It should work fine. I just said that I'm not having any problems with the 555 circuits. It's good. Yeah, it's blipping. It's good. So this capacitor is fine. And for some reason, sometimes it's not working. I have a problem somewhere. Hey! Oh shit! Check this out. This capacitor here. Yeah, this capacitor got fucked up. Yeah, bad capacitor here. This other leg flew off. These are very shitty capacitors. Unbelievable. Two bad capacitors. I was definitely getting some very strange error the last time, but I believe it was that capacitor. It might have been. Okay, this is not my usual value. I put a little bit larger value than I'm usually using. I'm using exactly 100 nanofarads. You can see it here. Probably 100 nanofarads, and this time I used, you cannot see it, but it's saying there 224. It means 220 nanofarads. I definitely need an LED to show me that it's pulsing, and I have no idea where to insert it, where to add it. I should probably, you know what, I can put it somewhere here. I can make a pad. I can put here a pad, and I can drag a wire directly from this pin to that pad. So that's the signal, and then add the LED, because I will have more space somewhere here, and a big resistor like this, and link it to the negative rail somewhere. This is negative rail, is going there. So from here I can drag a wire underneath, and here put an LED with a resistor, and then a pad from that output. And from that output I can then go forward on this other chip. That's what I can do. So from this pin 3 is good to have here an LED and 10 kilo to ground. I actually connected it like that, and this is not longer. Let me actually check it right now. It's working okay. No, it's not showing anything. I don't know why. Very strange. Huh? Maybe because I'm an idiot. I was using this blue one. Unbelievable. I didn't see it. I didn't see it. I was using the blue probe, and I'm usually using this other probe. Yeah, that was the problem. That's why I didn't see. Let's see now. Yes, it's working now. Now it's showing the correct waveform, the pulsing on my oscilloscope. So voila. It didn't show anything. It was showing me negative line. So it's staying high all the time and is pulsing to low. Also, the LED is showing exactly the same thing. It's staying high all the time and it's going low. I was using the wrong probe all this time. I was very sure I checked this marking on my probe and I didn't. I'm an idiot. Yeah, but stupid mistakes are made. It's good that I find the problems. Usually my probe is somewhere where I can put my hand on it. And it was this blue, this blue one, and the usual probe was stuck beneath elsewhere. 4017. Where are you? Yep, here it is. Let me take them out. This is a weird one. Probably this is scrapped. It's not the same as the others. The others are brand new. Unbelievable. Okay. This is my favorite, one of my favorite chips. Yeah, let me glue this first here, and then I will deal with the rest. There. So now I will make a very small board and I will glue it here that will contain the LED and the output from this 555. But first, I'm thinking to add a paper here to clearly mark that is a 555, like that. Like this. All right. Now I like it more than ever. Sometimes I'm having very weird errors, and I had these errors, very strange and weird errors, all my life actually. But I managed to deal with them, to get over them, to push forward. Even if I'm getting stuck on an error like that, I'm pushing the circuit, I'm testing everything until I'm finding the problem. That's what I'm doing. I learned. This is in my bag of skills right now. And I'm sharing it with you as well. Hopefully it will help someone to see how I'm dealing with errors. So now a small little pad specifically for the LED, and I also want to preserve this color that I started with. Let me check my shitty LEDs. I do have a very shitty one, but I want to get rid of it to use it. This is very, very shitty. Oh, I will not use this shitty one. This is the shittiest that I have. It's almost burned completely, but it's still working. Yeah, okay. This is a bit fucked up. Here. And I will make it larger. This is a bit more thicker cardboard. So. This is a small little detail that I didn't anticipate at the very beginning. So like this. And I think the ground wire, I will pass it underneath this potentiometer and link it there somewhere. All right. This is a weak LED, 620 ohms. This is a used LED, or a dying LED. It's a motherfucker. Resistor leg broke. Motherfucker. Look. Today I managed to fuck up 3 components, but these are very shitty components, that's why. And I know they are shitty, and I'm purposely using them. Let's find another shitty one. These are very special resistors. They are very, very shitty, and you have to leave a lot of wire, long wire, not to be very short, very close to its binding, what is having there, because that binding is melting probably. Let me actually test the LED, what I'm having already here, to see the luminosity, if it's good enough. Yeah, it's kind of good, although, yeah, it's good, yes. I wish it to be a bit more brighter than this. I will have to lower the resistance even more. Damn it, damn it. 330 ohms. I want it to be nice and bright. Kind of. A tiny little bit is brighter, but not as I want. So let's try with this 100 ohms then. I know I have some very, very bad components. Huh? Kind of. It's good enough. Yes. Very well that is running, that is working with such a low resistance value, but let me find a shittier one, a shittier resistor. It's looking okay, but it's not greater than before. I don't know. Yeah, it's kind of brighter a little bit, but not that much. Maybe it's a very tired LED, it's a very used, it's a very old and partially burned LED. I'm not using such low resistance values. I'm usually using very high values. And another scrap solder. Yeah. All right. Okay, so this LED should blip now. And it's extremely dim. Why the fuck are you so dim? Why are you so dim? It's very, very dim. Yeah, it's very shitty, that's why. I know it's the LED. It's kind of good, but not really. So I have to change it with a better one. Yeah. Oh, very good. So 1 kilo. Very shitty one. Let's see how the signal is now. It should be better, and it's not better. There's nothing. Unbelievable. And it worked 1 second ago, motherfucker. Alright then, the blue one. Good. Fucking finally. Fucking finally is good. Okay, so it's beeping. Yeah. 3 hours and 30 minutes until here. It is beeping fine. Good. 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 Okay. At 5 volts, by the way, not 9. This is using 9 volts here because it's using a battery. Next is to add this IC, my favorite actually. 0. Oh, very strange how this is linked here. 1, 2, 3, 4, 5. So it's having only 5 pins used. I really don't know if I should use it how he did it here or if I should reinterpret it and made it my way. But definitely I will have to link all these wires to some pads in order from all this very strange pinout. So as you can see, this is what I'm hating about this chip, but the functionality is very nice. That's why I'm saying this is my favorite chip, because of the functionality, but the pinout is garbage. They could have very easily ordered all the pinout inside with layers, with whatever, but they were lazy and stupid idiots. Okay, doesn't matter. It comes to me to make a board specifically for all outputs in order. That's the idea, and to be able to switch very easily to relink this wire if this circuit is not that good, because after all it is from internet, is actually from Facebook. But it's a very good idea actually. I really like it. That's why I'm making it here. Let me make a very short sketch here how the circuit should look like. And I'm also looking here. So the majority of outputs are here on this side, and only 1, 2, 3 outputs here, and the setting pins are also here on this side. So I can flip the chip, I can make it like this, I can turn it around like this to have all the settings on this side and all the outputs on this side exactly as it is in this diagram. So this is what I'm thinking right now, instead of wiring from this side on this other side to drag all the wires like crazy. I will still have to drag all the wires like crazy from this side, but it will be a little bit more easier. I don't know what to do. This is the problem. If you are turning it around, it will be a little bit more harder to follow, at least for you, the viewer, and also for me. I will have to concentrate a little bit more extra. But if it's on its normal position like this, face up, like here, it will be much more easy to follow. This reset pin, it doesn't need a capacitor here. Not really. You literally link it to the ground like this. It is clear this guy didn't know. He was experimenting stuff. So this is a logic pin, either 0 or 5 volts, or 9 volts in this case. Plus 3 volts to plus 15 volts. So that's why he is very sure that it will work with 9 volts there. Okay, so this chip is going to 15 volts. On the 555, 16 volts? Ah, here it is. Yeah, 16 volts. 4.5, which is 5 volts, to 16. By the way, I'm making a big mistake here, not testing everything like I'm usually doing on such a complex circuit. Not testing it with a breadboard, on a breadboard. And I should actually use the tested circuits, the tested components on the breadboard, actually use them in the final circuit, because that's the normal way I'm working. So right now I'm a bit a cowboy. Yeehaw! I'm risk it for a biscuit, and I'm making everything directly on cardboard, which is not a good idea, because I will definitely encounter some problems on the way, and I will have to probably to cut and to enlarge, make a little bit of space to accommodate new components or new spaces that are needed. So that's why it's good to have a breadboard first, and then to do the clean and the final circuit. What I'm doing right now is not good. It's not correct, at least in my book, how I'm doing things. So this is a very shitty sketch, what I'm doing here. So if I'm turning it around, I can actually link very easily from here. All these pins are also crossing. Okay, so it's not looking beautiful. Most probably I will not drag around, but I will go underneath on layers, and I will link each pin per layers with isolation. It's clear as mud. Right now I will do it the hard way. The hard way is the correct way. Usually is like that everywhere in life. You know what I'm thinking? I'm thinking to use a colored board here only for this circuit, because it will be very easy to see it. Like this, like yellow, without too many stuff. Only one single color like that. The color is a bit too strong. I will not be able to draw on top of it that well. It is not advisable to use color, but sometimes it's good to use color cardboards to evidence a module. I think I can make it until here. It would have been nicer not to have such a strong color, to be a bit more white-ish color. That's why I'm purposely using this a bit more whitish color compared with this, which is a bit more stronger and darker. And this will be the module for the 4017. Check this out. So this will be a single pad actually, linked here to the ground, and here a switch or a jumper connecting this pin to ground as well. If I'm deciding this reset pin to link it somewhere there, I can take it out from here and link it wherever I want on these pads here. And I have to leave space for the writing as well. So this resistor should be somewhere here, and the wire should go like that, and this like this. Probably I should start adding the 10 pads and conform to them. I have a ton of space here and here actually. If this will work, I will probably change this circuit with something else. That's why I'm adding all these pads. Theoretically, I should add only this 5 pads to actually respect blindly this circuit. I don't have to add all these pads. It's good to have options. You know, if I'm changing my mind, if I want to change this circuit with something else that is having more melodies, a continuation, I'm not sure. I want 10 pads, but all the same. I also want them to be able to catch, not to be glued. And large enough. This is one pretendent, 2, 3. Maybe I will change my mind and I will use more sounds, maybe more outputs than this 5. These are the best pads to work with, this square-ish pads like this. I'm not sure if they will actually fit. No, it's way too agglomerated. You know what? I can put one here and one here. And also I will have to number them as well. So I will have to leave space for numbering. And also I must put a pad here and another pad here for the power rails and also to secure this chip. Output 8, and it will be linked here to this last one, and this one output 9, it will be linked here. I'll have to deal with this side as well. Very tricky. This is a hard board. Yeah, you know what? I'm thinking right now to leave this last pin unlinked to anything, which is pin 11, output 9, not linked, because it's on this side. If I really need it somewhere in the future, I can easily add a wire from this last pin to whatever circuit I need to. I can leave only this 9, 0 to 8 pads. I can leave them as they are right now without one, because it's easy to connect it. That's why, if I really need it in the future. So I will leave it like this, somehow incomplete, but in the same time it's a bit more practical like this. All right. By the way, nothing is touching here. If you think something is touching, you are mistaken. This size dimension is dictating me what to do. Pin 9 will not exist, will not be implemented here. I don't have that many pads here, 3 pads, one larger one here, and this pad for this positive. And I have plenty of space here and here. Here I can put a resistor, and here I have plenty of space to put numbers. So this clock can be put here on the top, and also the text here. And this is clock enable here, and with 2 pads like here and here, also the resistor here to positive rail, and this pad can be even longer like this, also the text for the positive here, and the reset I can put it here, so not to interfere with this space that is very small here. This is clock here, and this is clock enable. Somewhere here I can add this reset pin, and here the resistor and the wire, the positive rail, and from here to the actual pin, here is a jumper, and this will be linked to negative rail. That's it. It doesn't matter if it's bent, if it's having this bending like this, because it will be glued. So these are the power rails or power pads of the chip, and it's good enough to solder the chip only on these 2 pads. Here, it fitted. Okay, and this last one, like this. Okay. Excellent. Probably another pad here, it will be a very good idea, but it will hold in only these 2 pads good enough. And probably this is it for the padding part. I can store them back. All right, good enough. Good enough for my family. Yeah, I really like this yellow circuit board. 2 hours at this point. He is using actually 2 ways of stopping the circuit, either stopping the clock or stopping the chip counting through this clock enable pin. That's what he is doing with these 2 switches. Probably is a good idea to have it here on the clock, but I don't have space for it anymore. It's already complicated as it is. Let's see this one here. if I will leave a little space, it will be a bit more nicer, a little bit more variation to actually see the module on this background. So that's the clock module on this background. That's another module on this background. Very clear. You can see it because of the colors. Interesting, no? Nice. I like it. I have to wire the pins of the chip. I have to solder it first right now. I have no idea if this chip is good or bad. This was different. This was before buying the new ones. This is not a new one, and I have no idea how good it is. I can probably test it very quickly, but we will see. We will see. I hope I will not have surprises with it. It looks clean. The pins are not used at all. It looks brand new, a little bit older than the rest of them. All right, so I prepare it. I will probably have to add multiple layers of isolation for all those intersecting wires that I will have to add here. And also I will strengthen this cardboard, which is very, very flimsy. Now I realized I didn't have to prepare the pins on that other side, only on this side I need them prepared. It's the habit of doing the right thing, I suppose. Okay, good enough. 2 hours and 10 minutes right now. Okay, now the wiring. The wiring is what we love, right? Quite a lot of solder I'm using for these little projects, and it's good that I'm having this scrapped solder from miscellaneous boards. This is not good. I need it a little bit more longer. It's a bit too long, but at least I can shape it. It is linked. Okay, one wire. The first wire is linked. This is the reset. Like this. 2 wires connected. Very good. So I'm having reset and clock. This nice text here. And now the outputs. 1, 2, 3. What? Actually, there are 9, and 1 I leave it unconnected by design. Clear as mud. This wire is actually dirty, but it is pure copper and it is very conductive. It's having absolutely no isolation. Right now what I'm doing here, I'm removing the dirt. So I definitely have to isolate this particular wire very well. The first output connected, which I believe is not used at all. But this board, it can be repurposed for something else later if I will dismantle this circuit someday. All right, if all the wires are dragged, yeah, probably I should glue it now. So I'm using quite a lot of glue. Here it is. I believe this is ground and I can connect it like that. I didn't think of it. I just realized it right now that I already have it there available. This is quite nice. I like it. It's nice and strong. All right. All right. First, I should put the resistor. Now I will use this schematic. So from here to here, 10 kilo. So I think I finished with the wiring. Okay. Looking good enough. This is the jumper. Excellent. All right. Also, I need positive and negative. Negative is actually connected, but I need a positive wire to here. Right now, I believe I can actually test it with an LED actually. And this is actually ground here. So we should get some blipping. I have 300. Something is wrong. I hope some wires are not making short circuit. Fucking hell. Of course we have some problems. Uh-oh. Uh-oh. Positive and negative. Seriously? Shit. Is this 10 kilo here? It is. If it's under it, I am screwed. Very strange. It might be because of this specific IC. I have a burned IC, maybe. Okay, you know what? I believe the IC is busted, and I didn't check it because I trust it. But you know what I will do? I will take out, motherfucker. I will take out its legs, at least the power legs, and test them separately. So now, yep. So the leg is up, it's not contacting anything, so I know for sure it's not the wires. This is a bit hard to take it out. Yeah, definitely. So the chip is bad, like shit bad. Motherfucker. I have no idea if it was already bad or just it's become bad while I was working on it. Yeah, I'll have to take out every wire from its pins. Alright. Good. Yeah, it is definitely bad. Motherfucker. Let's see if other pins are fucked up. No, everything is fine, but positive and negative rails are shorted. Bravo. Bravo. Fucking hell. I put all my trust in it. You see, if you are not using brand new chips, you are getting screwed. But I got screwed myself because I didn't check it. But how could I check it? Usually I'm trusting everything I'm having here. Let's say for the sake of redundancy, nothing is shorted. Somehow that chip got damaged. It must have been damaged from before, not right now. I probably use it and abuse it in some circuit. Maybe I overheat it. So this one is brand new. I'm preparing its pins again. Misfortune, I'm telling you. I'm having bad luck with this circuit. Let me check it again. Maybe they are too sensitive to overheating. No, it's fine. Yeah, definitely it was fucked up from other causes. And now these wires, I can barely see them. And now to solder every wire back as it was. Yeah, they are kind of on position already. Okay, back in business. Actually, I have to put this positive wire back. Alright, let's pray it will be okay. Okay, my power supply is telling me everything is fine. This is blipping. Now let's test. This is not correct. This is on all the time. It's not counting because it's to ground. Because it's to positive, so it was not enabled. Yep, yeah. And now I'm checking every output. Actually, I can speed it up. Yeah, yeah. Yeah, yes, it looks like every output is working fine, except this one. Yeah, I didn't link correctly at least. It wasn't linked at all. And now it should work. It is. Okay, good. And this is the 9th, which is not connected, but it's still working. There, so pretty much this clock enable is holding at some point, you know. Yeah, okay, good enough. It is working. What a shitty problem with that already burned chip. It was a little bit dubious because it wasn't brand new like this one, scrapped from somewhere, but it was clean actually. All the pins were clean. It was not used at all. Very, very, very weird, that chip. I didn't know that it might be damaged. I was very sure it was good. But from all the checking, what I did here, it turned out that it was internally shorted. I should actually put that diode protection also for this positive rail as well, for this chip. I'll actually connect it there. I'm using the protection for both circuits, this diode protection. Okay, good enough. And I should put an inscription as 4017. And voila. Wat rozjetszaptyszpy. Kunete, it means counter. Yes, but that's it for this part. 1 hour and a half. I have this stage. I have no idea how to make it with all these potentiometers. So this is 2 kilo, 5 kilo, 5 kilo, 10 kilo, 2 kilo. Yes, I'm thinking to use these ones, but I also have a lot of scrapped ones, which I very much like to use them instead of brand new ones. And I also have this model as well, but this yellow or orange ones are not as resilient to heat as these blue ones. They are melting and destroying very, very quickly when I'm soldering their pins. That's my experience, at least with these ones. This model, I mean. Yeah. Unfortunately, I really wished they were more resilient, more sturdy, but they are very, very sensitive. Probably because these blue ones have longer legs, a bit more longer than the other ones. Who knows? 2, 2, 5, 5, and 10. So this is 2 kilo here. I have these potentiometers for a very long time, actually, for a couple of years. And I don't remember I used any of them. They are brand new. I buy them just to have them as a reserve, but I never use them. You see how long is the leg? Very, very long. Most probably this is their secret compared with the other ones. They have a little bit more shorter legs. Probably that's the whole difference between them. Maybe. I'm guessing. I have no idea. Okay, so now I am forming them. Brand new leads, virgins, absolutely virgins. With 10 kilo, they are DM-ish. I can change maybe 1 kilo or 5 kilo. Yeah, definitely. Less than 10 kilo, a little bit, like 5 kilo or something like that. I will have to test it later. But they are fine, even with 10 kilo. So these are very brand new ones. How will I make this board? Yeah, I can actually drag the diode here, directly from this pad to this other pad, the new pad. It's having 1, 2, and 3 legs on it, so it should be very big. So this pad should be maybe like this, bigger. Let's see here, very to the limit. But I can make a cardboard that I will glue it on top of this, and it's okay if it will get outside. I'm not sure if I can fit all of this, can fit them all in this little dimension. And it appears I can, but the leads will not fit in. So I will have to put the lead somewhere in the front. I will leave this as it is, number 1. And number 2, here is the diode. I can put the lead here on top of this diode. It's a bit inversed, and I can link everything like that. This will be a little bit of problem, these pads, so this connection of the LED to the next, but I think I can do it, probably under the board, underneath it. Actually, the diodes are on pin 1, as you can probably see here. It's not starting with 0, starting with 1, 2, 3, 4, 5, and this is like that. Yeah, I believe it's possible. Alright, that's the diodes. It is good to visualize it. And also from this big pad, I have to link these LEDs, which are a problem because of my very small space that I'm having here. Where the fuck can I put the LEDs? The leg here, and there, and there, and there. Do you see my problem? Very shitty. And I will also have to include this resistor and another pad to the ground. So this drawing is eating the space for that resistor, for that last resistor. Fucking hell. I'm thinking on something courageous. To glue a piece of cardboard here on top of 7 and 8. So to isolate these two with a piece of cardboard, big enough actually, like this. And here to mount that resistor and link it to the ground. Because these two pads are not used. I put them there, but they are not actually used. So that's a solution. That's an idea. And to drag then a wire from all the legs of the LEDs. But where to put the LEDs? So this last resistor is kind of relatively solved here. Where to put the LEDs? I'm also thinking to enlarge this pad to make it even longer. I'm thinking this very long wire for the legs of the LEDs to pass it underneath on this cardboard, like a single wire under the diodes. But this is crazy a little bit. It's not good. If I have to change something, it will be very bad to change. But it's an idea. I'm also thinking to add all these legs in the air on top of the diodes and then link it there. And each leg of the LED linked to these pads, and then the other leg to be in air. Let me actually visualize it with some diodes here. So this is how it will look. Yeah, it will be a bit funky, but that's the nice thing about building on cardboard. Ideally, they should be here in the front, like here. Pack, maybe. With the legs in air is better. Yeah, that's what I will do. Very interesting. the final piece, I can add this diodes. Fucking hell. I don't believe I can actually work with this tip. I have to change it with this one to actually enter there. How can I enter there? I don't know. Without melting the plastics. Both the plastic of the LED and this potentiometer. Now I have to change this. And now it is hot. It is very hot actually. I can do this quickly here. Like that. Even if it's hot. Yeah, it's working a little bit slow, but I have more precision. Quite hard to reach there. And now I have to change it back while it's still hot. Okay. Okay. And now to actually solder it. Okay, this was not easy. And like I promised, I will put here on top of those. You know what? I can disconnect this wire and link it here from here to there, and that's it. If I'm disconnecting this wire, I can use this pad because this pad is floating, is not linked to anything. Like this. This is not connected. NC. And from there to there, 10 kilo, no? Like that. Perfect. I really like these resistors that are having text marked on them. Clear text, 10 kilo for this one. They are not bullshitting anybody. Not with dubious colors. I believe this LED should lit up when I'm powering this. Let's test this theory. Oh yeah. Check this out. I put a 10 kilo here. I said I will put less than 10 kilo, higher luminosity. Yes, I'm thinking to add here 5 kilo. I forget about it. So to have a better brightness on the LEDs. So 10 kilo, I'll put it back. I will use 4.7 because I have a ton of them. Yeah, you see? Here is the clear text 4K7. Very, very nice. It means 4.7 kilo. This NC not connected, it means it's not connected to the chip. That's what I meant. I didn't plan for this. This just happened. I chose the easy way. If this pad was also linked underneath, I was prepared to put a cardboard isolation, as you've seen me. Then I realized it's not actually connected. It was having that wire on top. So I'm making use of it. Let's see now the luminosity. And even if I'm having a lot of light here, it's still visible. Let me close. Yeah, it's good. They're lighting up a little bit, but it's okay. They are very sensitive LEDs, that's why. And they are not that sensitive. I have even more sensitive than this. Probably I know why they are lighting up. It's because of this variable resistors. So pretty much, if a positive signal is entering on this pin here, on the positive leg of the LED, that positive signal is also going through the resistor on this common line and is also feeding back these other LEDs that are on the rail, depending on the potentiometer how it's calibrated. Probably it should be wise to put these LEDs somewhere else than here. I was thinking actually to link them here directly on the pins of the chip, so this should be linked here. But I copy it as I find it on internet for the moment. But this is an easy correction to add. Let me actually finish it, and then after that we will make some corrections to it. But I'm happy that it's working fine until here. Alright, the final circuit, this one with the 555. It looks deceivingly simple, this circuit to make, but it's a bit more complex, and it took me already 2 days until here, and this day, starting right now, is the 3rd day. I didn't work non-stop on it, but I did put some good hours on it. I was thinking actually glue another piece of cardboard here only on this surface to level with this other cardboard, to stay on 2 pieces of cardboard and to elongate, to make it longer like that. That was the idea of this cardboard sticking out. But now when I actually have to implement this new 555 circuit, which I already have it here and I'm reusing this board, gladly I may add, that trick with the cardboard underneath is not really necessary. I have no idea how to stick it here. You know what is a good idea is to add another cardboard, bigger cardboard, and this one, smaller one, to glue it on that larger one that is fitting here. I don't know, or to do this like this, but it's a bit not easy to follow. It's an idea. Let me see first if I can mount all the necessary components for this circuit, these 2 capacitors and this resistor, and then this little module as well. So it's a bit more complicated, a little bit more adding this. I don't think I can make it on one board. At least this buzzer is taking a lot of space, and I should have prepared it, and I didn't. 30 milliamps. It should be like this. Okay, so I have this motherfucker as well to add it to the circuit. Here is my prepared 555. And I can modify this board. I can make it a little bit shorter than it is right now. Okay, so I can cut like that. So now it's smaller, and also on this side as well. And this is glued here. It can be removed. No, it is not glued. I thought it is glued, but it's not. And now it's even shorter. Perfect. And now you can cut it again and shorten it again. Okay, smaller is better, always. So we modified our board successfully, which is good. This is a lot of waste of space, but I really need this point here and also this one for these two capacitors. So this little board, I can actually glue it here. It will be better to be like this actually. I'm very undecided. If I glue it like this, I have space for this one here. 1 kilo. Let's see. Perfect. So that's the 1 kilo here. A capacitor usually is 100 nanofarads, 1.25. 100. And it appears, I find the scrapped one. And this is 1 microfarad. Here. These are my brand new ones. Yeah, this is perfect. As you can see, I'm not working with the sharp pointer. All right, excellent. And now wiring. As a general rule, it's always good to have a LED on the output of 555, almost in any circuit. Look how flexible it is, you see? Not good. So, 555. Clearly marked, because in the factory it's very hard to mark them clearly. And I should do it. Everybody should do it. Everybody, they should do it. Now the wiring, a little bit of wiring. 2 and 6. This is 2 and 6. Perfectissimo. This is 4 and 4. I like it more than ever. I will check all the links. Actually, I should link negative to there and to there. I have ground linked to ground and linked to ground. These 3 points are linked right now. 4 to 8, yes, there. 2.2 to 6 here. And from 7, which is this, a wire to there. And that's it. This is it. This is the entire circuit, what I'm having here. Mission accomplished. Yeah. It appears like I'm having quite a bit of space here left. This position is good enough for me. Now is permanent. Like this, here. The 555 module is finito. I only need to add the power wires, meaning the positive and negative. Yeah, probably a long black wire like that. And also here I'm having, for this module, and to here, and from here to there, I can link this ground wire. I will make this little module, which is very simple actually. It's having only 2 pads, probably. Yeah, and larger pads. And also this capacitor there, I should think about it. This is the Legacy St. George cardboard. I can use this because it's red. I'm using this one because it's red. It's a clear module. It's a bit colored, everything. 1 microfarad. Really? 1 micro? I should use this 1 micro 50 volts. So this is the old glue. Okay, good. I didn't have to use this glue. Negative, positive. Good. And now this little sunshine. Excellent. Yeah, this capacitor is overkill here. So I still have some very good amount of room here. I specifically designed it like this to leave some room for the LED and the resistor if I will decide to add them later. By the way, this is a scrapped cardboard that I re-scrap it right now. This little cardboard. This is the Legacy of St. George cigarette package cardboards from my very beginning when I started to build on cardboards. It will be a little bit tricky to get there with my fat soldering iron. This is looking like a Lego, almost, but hard work Lego. So a negative wire from there to there. Let's not melt the plastics. Good enough, that one. This is the output. Why I'm collecting it from this point here and not from there, because this is the reset pin which is connected there. And if I'm changing my mind and I want to disconnect it from the ground and connect it somewhere there on the pins, this is the motive why I'm linking everything there on that point and not here, where I have clearly a lot of space and is even bigger pad than what I'm having there. I'm preserving that pad for its functionality pretty much. Okay. Yeah, you know what? This is long enough, actually, this wire. Let me check something else. If it's from there to here, and it appears it is. Yeah, perfect. So this should be like this. This should be like this. I can make it work. Yeah, it's good. Let's see if it's singing. I have to calibrate it first, but let's see if it's doing anything. I know why it's singing like that. I didn't put this wire from pin 7 from here to here. Let's see now, hopefully. It is changing something there. Yeah, I'm very disappointed because now it's outputting all the time. It's keeping high instead of keeping it low. Let me oscilloscope it. Here I'm receiving gibberish on my oscilloscope. But I'm thinking maybe this buzzer should be connected in reverse, maybe? So when I'm getting a signal on these LEDs or outputs, it's going down to 0 volts, but all the time it's keeping it up to 5 volts, that output pin. That's the problem. And it's beeping all the time. I should invert the signal somehow with an inverter, usually. So here I'm having 3.8, almost 4 volts on the output here from 5 volts. Okay, I'm having 4 volts here. On the circuit diagram here, I can put an inverter like this. But here is a bit more complicated because I have to substitute to put it somewhere in place of this wire. So if I'm inverting this signal, I believe it will do its job. I don't know how to invert the signal using only the 555 circuit. I'm not that good. But theoretically, it should be possible. Probably, I'm thinking. But I'm not that good to be able to think in that logic. And I also hope that I connected everything correctly. But it is buzzing, and I can hear when these LEDs are activating. I can hear a difference in buzzing, and also my oscilloscope is catching here on the output a difference in buzzing when these are lit up, and when they are not lit up, is going straight to the positive rail, pretty much the output, which is not 5 volts, but the maximum positive rail that this output can deliver, and it's about 4 volts. Because also I'm having this diode in circuit that is lowering the entire voltage a little bit less than 5 volts, probably. It is shitty that is not working from the first try. And I didn't made a simulation for this circuit in my Proteus. I just jumped directly in building it, trusting it blindly. Yeah, I'm still making stupid mistakes even at this age. I should know better, but I don't. Yeah, I have to add an inverter. I can use this just to test the motherfucker. 7414 like this. And I will have to drag some wires. Okay then, positive here, negative, positive, and negative there. So positive, negative, and this is the gate, input and output. I'll have to probably to interrupt from here. So this is the output of the 555, the input of my inverter. This is the output of the inverter. And let's hope it's working correctly this time. Come on, baby. Yes, it is. Yes, it is. Yeah. So all it needed was that inverter there. Look how beautiful it's singing. What a beautiful melody. You never hear such a beautiful melody in your life. I also have some specifications here. Actually, I should calibrate it. It is saying to calibrate it using an oscilloscope. So I'm having already my oscilloscope here. And this one I should put it on the, where? On the output? Which output? The output of the inverter, I believe. Yeah, probably there. Let's hope it's good enough. I need to actually step the sounds. So now I'm realizing that I actually need this little element here to actually step. But this was my idea, to step it very slowly and to catch there, but like that. So the frequency right now I'm looking there is 19 hertz. Really? 19 hertz? I need probably this is the order G4, A4, F4. I have no idea. Probably these are musical notes or something. 392. Let's see if I can reach that frequency. Hertz. 33 hertz. Are you kidding me? Because my oscilloscope is shitty, that's why. I cannot reach 392. So I will make it 292 because I can lower it down. Okay, 292 there. And let's see the second one. Come on. Yeah, 3 is good. 3, let's see. 349. 249 maybe. 248. There. Here. See? Frequency? That's where I'm looking. And so this is 3 here. Let's go on to... And it's jumping like a fucker. Maybe I can catch it. On 2. Come on. It's probably jumping, that's why. Yeah, yes. 440, so it's 340. And I cannot reach that value at all. Yeah, 338 is the fourth. Yes, that one. That is the one. The fourth is 175, which is this. Let's see. So for some reason I don't have this very high value, very high frequency, 440, and this 392, which I started with. So let's enable it now. So I lowered with 100. Instead of 392, I put 292. Instead of 440 hertz, I put 340 hertz, and so on for all of these values. That's what I did. So I lowered with an octave. I believe is the term in music. I'm not sure. I'm not good in music. Let's hear it out loud. It's kind of doing it. It's kind of doing it. It's creating a beautiful music. The rest are correct, but the second one is shitty. Yeah, you see, when the second one is lighting, everything else is lighting up. Why is that? Yeah, it's working. Unbelievable. And also we can increase the speed. Okay. Enough for the oscilloscope. So the project is a success after all, with some little problems on the way, but it's nothing that we cannot solve, right? So I'm taking out these wires. I do have a lot of inverters actually. I believe these ones, which are very, very, very small, these SMD ones, is still 7414, exactly like that one. These ones, you can see them. But I don't want to use one of those because are pain in the butt to work with them. I have another idea. I have this 100 of them, which are a bit nicer to work with. I'm wasting a lot of gates. I'm only using one single gate from it. But, you know, that's what I need. So 7414. This is what is happening when you are building circuits and not testing them in my Proteo simulator. And, I am stupid. Sometimes I am. I think I can do it without any kind of checking, but apparently I'm not that good. I am good, but not that good, as I'm used to saying. You know what? I have a bright idea. Either mount this NOT gate here on the back, or add another cardboard and put an extension, like a little bit of space, and in that space to mount this NOT gate and to connect it correctly there. I believe it's more nicer to have it here somewhere on an extension. I only have to drag exactly 4 wires to it. I can actually glue this chip here. I can put a little bit of glue. Probably I should glue it right now, because the wires, yeah, I should glue it there right now with a ton of glue. And I will not put it right on the bending. I'll leave a little bit of tolerance. From experience, I will leave it like that. So this is how it's looking from the heightness perspective. Is not that high. And I believe I can make a box for it, probably. On my breadboard, in my testing earlier, I connected these two pins and I used this gate. But here, if I have to use exactly this gate, is right there. Yeah, you can see it is right there, and it's very inconvenient from there. But I'm having either this gate or this or this. Probably this one is more convenient to use because it's here in the margin, so I can drag the wire from here to there. That's the input, and this the output there, and it will be as good as the other one. Doesn't matter which gate you are using. You have 6 spares pretty much, whatever gate you want to use. And in my case right now, I believe I will use these 2 pins for this single, for this fourth 1 2 3 4 5 6, this number 4 gate here. Hold on, I have a ground here as well because of this wire, so I can drag the ground from there. Very convenient. And the positive, I have to go there. Oh, good. It's good that I catch it. It's good that I've seen it. Actually, it should be a bit more than 5 volts because I'm having a lower voltage overall in all the circuit when I tested earlier. 4 point something volts instead of clean 5 volts. And my power supply is actually giving me 5.1, 5.2 already, and it was quite lower. So here it should actually be 6 volts. It's better to be 6 volts to have the entire circuit running at 5. Most probably because of this voltage drop on this input diode. That is the first one there. Is not 0.7, is less, 0.5, something like that, volts drop over this diode. And this is affecting the entire circuit. But it's very good to have it for stupidity reasons. I was stupid. My experience is including stupidity. Putting the inverse polarity. You need the fine tip for very special occasions, for very special chips or components, but not all the time. Especially for my circuits. Okay, that's the negative rail. I want a clear blob. Okay. So what I'm doing right now, I'm guiding this wire through these holes to stay on the same position all the time, not to move around. This is like a book with a chip on it. Very cute, huh? Good blob. And for some reason, I lost my last part of the video where I was testing, but this is what I did the last time. I mounted this chip here, this wire, which is negative, this positive wire here, this signal wire that's coming from the output into the input, and from this output here. And let's actually test it. The most beautiful music in the world, and you can dance on it. The idea is that you can tune each potentiometer whatever you like. This leads, that's why, if it's on the maximum, is creating this error. If it's rotated to the maximum, it's not doing it right. Yeah, this is it. It was a bit hard to make it, but in the end, it's made. I really liked the idea of 4017 inside all this circuit. Every time I'm finding a new and interesting circuit with 4017, one of my favorite chips, I'm jumping very quickly into it to build it. This is a special way of using these chips with 2 555s and also a NOT gate in the very end, this 7414, that saved my ass and the project itself. Everything I build here, the way I'm building, the way I'm showing, presenting, my way of doing things, I really hope it will help somebody else, some of you that are trying this stuff, facing problems, facing errors. And this way of doing electronics, like I'm doing it, is both teaching, learning yourself to do it the hard way. This is the hard way. But I believe it's the best way because you have to keep in consideration errors. You have, your mind is split into working and errors. It is like I'm saying it. You always keep an eye on the errors. You know they will come. They will not leave you. They will appear in one form or another, for one reason or another. Doesn't matter. But they will come. Either the circuit is incomplete, either you make a stupid mistake somewhere, or just a normal mistake, or just a random mistake that just happened, a faulty component like my first 4017 that I mounted here. It wasn't my fault per se, although I'm testing all my chips. I didn't test that one specific one, to be sincere. I took it and placed it there in the box. Who knows? I have other chips brand new. This one was one of those brand new. Also, this circuit mistake that the original didn't have it. This one here with the LED is very good to have, this output LED. This one that I should have inserted there, most probably, to be a bit more precise when I'm switching between steps instead of me playing there. You learn a lot, and you face a lot of problems. You learn from everything, and it will burn into your brain. This entire experience, as hard as it is, all this exercise, all these failures, the repairment, the attention that you have to put in it, not to fuck it up, everything, it will pile up is little by little like that, is small steps, making one single big project that is actually working. And how useful or practical is this particular circuit? It's probably not that practical, at least for me. But personally, why I choose to do it is to use to practice new ways of using 4017. It's just a new circuit that is doing something different from all the circuits that I built so far with 4017. And why not with 555s? And this circuit can be actually put in practice as a module in itself, this musical module, like a circuit board. Thank you very much for watching, for everything, for understanding, and see you next time with the next project. And I say to you goodbye from your favorite artist electronist, Mr. Q12. Bye bye. Ta-da!